Hi and welcome to this on Maths prediction for the OCR Paper 5 Higher Tier Maths GCSE. Enjoy! Hi and welcome to this prediction video from On Maths. Now what this prediction is we look at all the previous exam paper questions and see what comes up regularly and what's long overdue to come up and create this predicted paper. You can do this predicted paper online for free if you click up here. And on our site also is Topic Busters, which is basically just specific topics with all the questions based on those. And we've got Topic Busters for every single topic. And you can also check out the Revisionator, which is quicker and shorter blast of random questions to help you revise. You can sign up for free. In fact, everything on our website is completely free. Please make sure that you use this as part of your normal revision. Don't just fully rely on this paper because it is a prediction. You need to just use this as a revision tool amongst all your other revision stuff. Don't forget also that when you do this online, the numbers will be different. The methods and questions will be the same, but the numbers will be different. So you can do it multiple times to see if you improve. I hope you enjoyed this video, and if you do, please click like. And if you want to see more from us, please click subscribe. Thank you very much. When solving, always just write out the question and put down lines either side of the equals. And what we're looking at doing is doing something to both sides so that we get x on its own. So we want to end up with x equals at the bottom. That's when we know we've solved it. So looking at the left hand side, we need to get rid of this 6 here and the take away 6 there. Now we must remove the plus or the minus first, as long as it's not trapped in a bracket or a fraction. So we're going to get rid of the minus 6. To do that, we need to do the opposite of it. So we need to add 6 to both sides. So we're going to end up with 6x on the left hand side, because we've got rid of the minus 6. And we're going to add 6 to that to make 60. Now we want to get rid of the 6 before the x. Now that's a times 6. When you put a number next to a letter, it's a times. So to get rid of it, we need to divide 6. So we're going to end up with x on the left hand side, and 60 divided by 6 is 10. So the answer is x equals 10. Didn't need that much room in the end, and that's it.
When you're asked to describe the relationship between two things on a scatter graph, the sentence you need to write is, as this one increases, this one either increases or decreases. So as time of day increases, test marks, and because they're going up, it's a positive correlation, test marks increase. So there's a difference between describing the type of correlation or writing the type of correlation and describing the relationship. When you're describing the relationship, it's just as the one at the bottom increases, the one up the side either increases or decreases. So it says, using the scatter graph, the examination centre then conclude that time of day leads to positive effect on test scores. Are they correct to make this conclusion? Basically, this is a question about the fact that just because two things correlate does not mean that one causes the other. So a sentence like, there may be other factors such as, I don't know, what else? Tiredness, fatigue, tiredness. So try and make sure you give an example as well to support your argument.
At first glance, this seems like a really easy question. It seems like the answer will just be 80. But we've got to understand the way that bearings are written out. It says work out the bearing of A from B. It means that we are at B and we're trying to find where A is in relation to B. So the actual question is asking you for this angle here. Now don't forget, bearings are the angle going clockwise from north. So not so easy. The first step of doing this, and there are different ways of doing this, is just draw a line. In fact, I'm going to use my straight line one. Just draw a line straight down at B. If I can get it right, there we go. Now, north lines are always going to be parallel, and we can use that to work out this angle here. This angle here will be the same as this angle here, because they're Z angles or alternate angles. So that's also going to be 80. We know this one is a straight line, so we know this is going to be 180 degrees. So all we need to do to work out the bearing is do 180 plus 80. And when you add them together, you get 260. So the bearing is going to be 260. Now there are other ways of doing it. You could have worked out this angle, because this angle and the 80 degrees over here are co-interior, interior, or allied angles, whichever one you want to call them. So they will add up to 180. So we know that one's going to be 100. And then what we could have done is 360 take away 100, because it's the full circle is going to be 360, and we don't want that 100 one. You'd also get 260. Question A seems like a really complicated question, but it really isn't. If you think about what you know about a rectangle, you know that opposite sides of a rectangle are equal. So if you just write down x plus 1 is the same as 12, and then solve it. So what we're going to do is we're going to take away 1 both sides. Then x equals 11. So we know that x is 11. Let's check that out. It says here x minus 1. Well, what is 11 take away 1? Well, it's 10, and that is the same as that. So we know that x equals 11, and that's it. Question B, have a think about what you know. You know that all angles in a triangle add up to 180. So we know that if we add y, 2y, and 3y together, it's going to equal 180 degrees. So again, let's just get our lines down so that we can solve it. So 1y plus 2y plus 3y, well, that gives us 6y in total. And then what we need to do is get rid of that times 6 there by dividing 6 both sides. So y equals 180 divided by 6. Well, I know 18 divided by 6 is 3, so I know that's going to be 30. Okay, so this question is a little bit more complicated than it first seems. So we've got Adrian, Ben, and Charlie, and they share some sweets in the ratio of 6 to 3 to 8. And it says that Charlie got 12 more sweets than Adrian. Well, first of all, let's have a look and see how many more parts that Charlie... Oh, always cross my L's for some reason. Charlie got more than Adrian. Okay, so he got 8 take away 6 is 2. So he got 2 more parts. And so let's have a look and see what 1 part is worth. So those 2 parts equates to 12 more sweets. So we do 12 divided by 2, 6. So each part is worth 6 sweets. And it says work out the total amount of sweets. So we need to work out how many parts there are in total. So we do 6 plus 3 plus 8. Now I know 6 plus 8 is 14, plus 3 is 17. So we've got 17 parts in total. Each of them is worth 6 sweets. So to work out the amount of sweets, we do 17 times 6. Now we could do 7 times 6, which is 42, 10 times 6, which is 60. So add the two together, it's 102. So there are 102 sweets altogether.
Okay, so for this question, the first thing we're going to do is we're actually going to convert these into easier numbers to deal with. So I'm going to times this left-hand one by 10 and times this right-hand one by 10. So we actually end up with whole numbers, which are much easier to multiply. I've just got to remember to turn them back at the end to deal with that at the end. So there's multiple ways you can multiply this together. You can use the grid or column or whatever method you feel comfortable using. So let's put these in a column. But again, there's no additional marks if you do one way or the other. Okay, so 5 times 3 is 15. Carry the 1. 5 times 1 is 5. Add the 1 is 6. 5 times 7 is 35. So it'll be 35. Now the next thing we're doing is 40 times 3. So what we're going to do is just add a 0 here, and then we can just think of it as a 4. So 4 times 3 is 12. 4 times 1 is 4. Add the 1 is 5. And 4 times 7 is 28. Then we're going to add going downwards, so 5, 6 times 2 is 8, 5 times 5 is 10, so it would be 8 plus 3, which is 11, plus the 1 is 12, and then 2 plus the 1 we carried, which is 3. So this is going to equal 32,085, but the problem is we times two numbers by 10, so we need to undo that. And we do that, undo it by dividing it by 10 and then dividing it by 10 again. So in total we've divided it by 100. So it's going to be 32 with a 0 and then 0.85. So the answer is 320.85. And normally you can just check to see roughly whether that's right. So 71 is roughly 70, 4.5 is, I don't know, roughly 5. So 7 times 5 is 35, so 70 times 5 is 350. Well, 320.85 is not far off 350, so we know we've probably got it right.
Okay, so for this question, we're given a plan of a garden, and we're given a set of instructions of where the tree can be planted. So it says that we can't be any closer than 5 meters, so at least 5 meters away from point C. So that's from here. So let's have a look at that first. Now I'm going to find it very difficult to make this perfect because I can't draw circles or arcs on this. However, I'm going to try my best to show you roughly what it should look like when you do it on paper. So you need a compass for this, and with the compass you would measure out 5 centimeters, which I'm sure that's the scale of this. So you'd measure out whatever it says the scale would be. So for this one, I'm imagining 1 meter is 1 centimeter. And you would draw a kind of quarter circle with your point of your compass at C, and you draw like a quarter circle like that. And that's not too bad, although it looks it looks closer to B than it should be, but it's not too bad. Okay, so that's that first bit sorted. Now it says the tree must be closer to CD, which is this bit here. So it's got to be closer to this than AB, so than this. So what we need to do is ensure that it's closer to the red line than the green line. Now to do this, you need to do a perpendicular bisector of AD or BC. Either one would work. So you get your compass and put it at point A, and you measure out something that's more than 5 centimeters. It doesn't matter how much more. And you do an arc, like a bit of the circle this side and a bit of the circle this side. You do the same at D, and you do a bit of the circle this side and a bit of the circle this side, and then you join those up. So I'm going to join those up and just keep going like so. Now that will give you a perfect equidistant line from AB and CD. Mine's a little bit high, as you can see, but on your one it should look perfect. So it says shade the region the tree can be planted. So it's anywhere, and I might do a different colour for this so it just stands out a little bit. It's anywhere here. Now you always just double check this. So the blue shaded, and on your exam don't bother with a different colour, just use a pencil to shade it in. It says the tree must be at least 5 metres away from point C, which mine is, and the tree must be closer to CD than AB, which mine is. Okay, for Venn diagrams it's really important to understand the notation. This symbol here means union, it just means or. It means it can be in A, or it can be in B, or it can be in both. So it's any number inside either circle. So I could have 9, 5, 3, 7, 18 or 2. Let's go for 9, but the other 5 would be correct. This symbol here, I always view it as an and. I always put a little line there to say A for and. And it means it needs to be in A and B. It can't just be in A, it can't just be in B, it needs to be in both. And there's two numbers that fit that bill, 3 and 7. So I could write 3 or I could write 7. Now this little symbol here, okay, and it's an A with a dash. That dash there means not. So we're looking for numbers that aren't in A and are in B. Well, let's have a look at where not A is. Well, it's anywhere around here. Anywhere around here is not in A. And let's have a look at where B is. So B is anywhere here. So the numbers that overlap both of those are the 18 and the 2. So it's 18 and 2. So there are two numbers that fit that bill. So that will go at the top of our fraction. And there's 1, 2, 3, 4, 5, 6, 7, 8 in total. Now I can simplify that a little bit to make it a quarter. And so my answer to that will be 1/4, or a quarter. Right, whenever you're asked to estimate, basically what that means, it normally is round everything in the question to one significant figure and then work it out. Now there are a few exceptions to that. For instance, if you're asked root 82, the easiest thing to estimate that to is root 81, not root 80, because you know what root 81 is. Root 81 obviously is 9. But mostly it's one significant figure. So we're going to go through everything in the question and just round it to one significant figure. Now, 64, for 64, the line goes after the first digit for significant figures. That 6 will stay as a 6 because that 4 is less than 5. And that 4 will just turn to a 0. For 160, the line will go between the 1 and the 6. That 1 will round up to a 2 because the next number is 5 or more. And the other numbers will turn to 0. 22 at the bottom, line goes down there, that rounds to 20. 98, line goes down there, the 9 will go up to a 10, and the 8 will turn into a 0. So that question turns into 60 times 200 over 20 times 100. Now there's different ways of doing this. I mean, we can multiply them out. So 6 times 2 is 12 with 3 zeros. 2 times 1 is 2 with 3 zeros. And then we can just cross off the zeros. So 1, 2, 3. And then we're left with 12 divided by 2, which is going to be 6. And when I say cross off the zeros, what I'm doing is dividing top and bottom by 10, and then by 10 again, and then by 10 again. So the answer is 6. There are different ways of doing it. I could have cancelled down at this stage here and divided top and bottom by 20. So that would leave 10 there. And then divide top and bottom by 10. So that would leave 10 there. 60 divided by 10 is going to be 6. Loads of different ways of doing it. Okay, first thing to realise with this question is how you calculate the mean. The mean is the sum of all the values over the amount of the values. Now this actually creates a triangle, just like speed, distance, time triangle. works in the same way. So we have mean here, we have the sum at the top, and the amount at the bottom. So we normally do the sum divided by the amount, but actually with this question we need to go the other way. And we need to work out the sum or the amount or whatever. Let's have a look. So it says there's 12 boys and 8 girls. So in total there's 20 children. So that's the first thing we need to realise. It says the mean number of coins for the children is 15 and the mean number of coins for the boys is 13. And we've got to work out the mean number of coins for the girls. So we know how many girls there are, which is 8, but we don't know the total amount of coins for the girls. For the boys. Okay, so where do we start? Well, it would be helpful to work out how much coins there are in total. So if I look at the triangle there, we know, so let's write down total children. I'm going to try and show my working out as I go. We know that the mean of all the children is 15. So in my triangle, I've got 15 for the mean. We know that there are 20 children in total, and we can work out the sum by timesing those together. So we're going to do 15 times 20. So there's 300 coins altogether. Okay, so now next we're going to work out, well, we're given the boys. So let's work out how many the boys have. So same triangle. We know the mean for the boys is 13, and we know that there are 12 boys. So we're going to do 13 times 12, which is 156. So to work out how many girls there are, or to work out the sum of the girls, we're going to do the sum of all the children, which is 300, take away the sum of the boys, which is 156. So we'll do 300, take away 156, which is 144. So we know what the girls add up to, because if the boys add up to 156 and the total children adds up to 300, then the girls must add up to 144. But we're asked for the mean for the girls. So to work out the mean, we just go back to our standard formula we had at the start, which is this one. To work out the mean, it's the sum, which we worked out as 144, over the total, and it says there's 8 girls. So we do 144 divided by 8, which equals 18. So our answer is 18. Okay, this is quite a lengthy question, and again, it's one of those questions, there's multiple ways of doing it, so if you've got a technique that works really well, stick with it. But with this question, and with any fraction questions, you need to make them top heavy first. So that's what I'm going to do with both of these fractions. So 6 1/3. And to make it top heavy, you times by the bottom, and then that answer you add to the top, and then you keep the bottom the same. So 6 times 3 is 18, add to the top is 19, but keep the bottom the same, so it's still over 3. So 4 1/2, we times by the bottom, which would be 8, and then add it to the top, which would be 9. So that equals 9 over 2. So we're going to do 19 over 3 times 9 over 2. So I've written the same thing, 6 1/3 times 4 1/2, but instead of 6 1/3 I've written 19 over 3, instead of 4 1/2 I've written 9 over 2. Okay, so one thing you can do at this step, which will help us write it in its simplest form, is you can divide anything at the top and anything at the bottom by a number to simplify it. So the 9 at the top and the 3 at the bottom, I can divide them both by 3. So that will leave 3 at the top there, and it will leave 1 at the bottom there. Now, this is really important because if I times these across, I would get a really big number. Now, I'm still going to get a big number, but it's a lot smaller and a lot easier to spot how to simplify at this stage. Okay, and some people call this the Bowtie method because if I draw a nice bow tie over it, it can be any number at the top and any number at the bottom. So it can be down here, or diagonally across, hence the Bowtie method. So now instead of doing 19 times 9, I'm doing 19 times 3, and you can do any method you want. I mean, some of you would do 20 times 3 and take away 3, but Let's do a little grid. 19 times 3, 30. 3 times 9 is 27. So 30 plus 27 is going to be 57. And now we're doing 1 times 2, which is 2. Now it says that it wants it as a mixed number, so we need to do that now. So 57 over 2, we need to make that mixed number. So we've got to work out how many 2's there are in 57. Well, I know that 56 divided by 2 is going to be 25 plus 3 is 28. So there's 28 whole ones and 1 remainder. So what you do is you work out how many 2's there are in 57, which is 28, and then any leftover, any remainders at the top, just create the fraction. So the answer is 28.5. Okay, there's more than one way to expand and simplify a single bracket. You're essentially doing the same thing, but some of you might want to draw grids or do it in a different way. I always just use smiles and rainbows, so I just create a smile between the 2 and the 3x, and a rainbow between the 2 and the 6, and I put a little time sign there to remind me to times it. Just put a notch through the bracket. That means we're going to times 2 and 3x, and 2 times 3 is 6, and then we've got the x there, and 2 times 6 we're going to times together to make 12. Now we've still got the 4x, so I still need to write that down. Then I'm going to collect like terms. Now the like terms we have is the 6x and the plus 4x. So 6x plus 4x is 10x, and then there's nothing that we can do with the 12, so we just leave that. So it's 10x plus 12. Okay, the next one, there's a double smiles and rainbows. We've got one here, put a little time sign there, and we've got one here. So we'll do the first one first. So 8 times 6x, so we do 8 times 6, which is 48, and then we've got the x. Then we do 8 times positive 2, which is 16, so plus 16. Now that's nice and easy. However, the next one's slightly different. The number outside the brackets is not a 3, it's a minus 3. So when we do minus 3 times positive 4x, we're going to get a negative, because a minus times a positive is a negative. Then we do 3 times 4, which is 12, and then we've got the x as well. Now the rainbow is minus 3 times minus 5. 2 minuses times together is a plus. 3 times 5 is 15. Then we look for like terms, so we've got the 48x and the minus 12x, and we've got the plus 16 and the plus 15. So we want to do 48 take away 12, or 48x take away 12x. So if we take away 2, it's 6. If we take away 10, it's 36x. Then we want to do 16 plus 15. Well, 15 plus 15 is 30, so that's going to be 31. So the answer is going to be 36x plus 31. Now the most common mistakes are for that n bit there, this bit here. Sometimes students will write down negative 15. Okay, so in this question, you might think that to get the answer to this, you do 40 divided by 5 to get to 8, so you divide that by 5 and you get one machine. The problem is that doesn't make any sense. If 5 machines take 40 minutes, that's almost an hour to make one toy, then what, one machine's going to do it in 8 minutes? It just doesn't make sense. And a question like this that doesn't make sense, if one increases, the other increases, is an inverse proportion question. Now there's an advanced way of doing it where you work out the formula and you do it that way. I'm going to show you a slightly different way that's maybe easier for some people. So if you think about the machines, which is one variable, and the time, which is the other, and we've got 5 machines and it takes 40 minutes, then if we times those together, we get something which I'm going to name machine time. Okay, I've just made that up. So 5 times 40 is 200. Now that 200 there is really special, because that 200 must always be the same. the machine time must always be the same. So it says we want to do it in 8 minutes. So I've got to think, right, what times 8 is 200? Because machine time will always be the same. So I get my calculator and I'm going to do 200 divided by 8, and it's 25. So let's check that. 25 times 8 is 200, so it works. Now, that is the answer, that we would take 25 machines. Let's just check if it makes sense. So 5 machines take ages. They take 40 minutes to make a toy. Yet 25 machines take only 8 minutes to make a toy, so that makes sense. You'll notice that we've divided that by 5, but we've times this one by 5, and that's the way inverse proportion works. As you divide one of them, you times the other. So to answer this question, we need to be really familiar with the formula y equals mx plus c. Now y and x will constantly change, but m is what we call the gradient, and c, or plus c, is what we call the y-intercept. Okay, so we need to understand how to use that formula for this question. Now it already tells us that the gradient of the line is 3, so we can fill that in. So it's y equals 3x plus c. Nice and easy. The only thing we don't have is the y-intercept. Now the way of getting the y-intercept is substituting in the values we know. We know when x is 3, y is 17. So what I'm going to do is just put in the values. Put in the values of 3 for x and 17 for y. So it's going to be 17 equals 3 times 3 plus c. And I'm going to put my lines in so that I can solve it. So that's 17 equals 9 plus c. And we're going to take away 9 from both sides. So it's going to be 8 equals c, or just c equals 8. So looking back at this formula we had earlier, we had m but we didn't have c. Well, we now have c, which is 8. So it's y equals 3x plus 8. And you can check that by putting in the values of 3 as x and see whether you get 17. 3 times 3 is 9. 9 plus 8 is 17. Okay, there are 2 things you need to know, main things you need to know about kind of advanced number indices. And the first one is that anything to the power of 0 is not 0, but it is 1. And the reason being is, say we had 10 squared divided by 10 squared, that would be, take away the powers, so that would be 10 to the power of 0, because when you divide you take away the powers. But any number divided by itself is 1. So therefore anything to the power of 0 is 1. The second thing you need to remember is if you have a negative power, all you do is you get the number, it's 3 to the power of 1, which is just 3, and put a 1 over it. So if you had 2 to the power of minus 2, that would be 1 over 2 squared, or a quarter. So the negative just results in putting a 1 over it. Now if you have a fraction, and we do it to the power of a negative, you actually just flip the fraction. And that's it. That's called finding the reciprocal. So there we go. If you ask to find the reciprocal of something, you just put a 1 over it if it's an integer, if it's a whole number, or just flip it if it's a fraction. Okay, these are simultaneous equations, and I'm just going to write these out again so I've got a bit more space. So equals 63 and 2x minus 6y equals 0. Okay, so the important thing with simultaneous equations is that you need to either get the coefficient, the number before, the x, or the coefficient of the y the same. Now in this one we already have the coefficient of the y being the same. They're both 6. Yes, one's a positive, one's a negative, but we don't worry about that. And with simultaneous equations, we work downwards, which was step 2, but in this one, because the question has been nice, it's going to be step 1. Now we look at the signs for the one with the coefficient that's the same. So the y's have a 6 before it, so we're looking at these signs here. Now, if they are the same sign, we subtract. If they are different signs, we add. And it's that simple. Now, they are different signs, so we know we are going to add. So we're going to add going downwards. Okay, so 5x plus 2x is 7x, and we're going downwards. 6y plus minus, well, the minus wins a plus minus, so 6y minus 6y is 0, and it has to be 0, otherwise we can't answer this question. And 63 plus 0 is just 63. Then we put our lines in to solve it. So 7x equals 63, divide both sides by 7. So we have x equals 9. Okay, now next we're going to pick one of these equations to substitute that 9 into. I'm going to pick the first one, but I could probably easier to pick the second one, doesn't matter. So I'm just going to rewrite this first equation. But instead of 5x, we know it's 5 times 9 plus 6y equals 63. I'm going to put my lines in, and we've got to find out what y is now. So 5 times 9 is 45, plus 6y equals 63. And then what we're going to do is we're going to take away 45 from both sides. So we're going to do 63 take away 45, which is 18. So 6y equals 18. And then we're going to divide by 6 both sides, so y equals 3. And what you can do if you've got some time is just put it into the second equation. So we're going to do 2 times 9, which is 18, and 6 times 3, which is also 18. So 18 take away 18 is 0. So the answer is x equals 9 and y equals 3. Okay, so here we've got a box plot, and it's important to understand the parts of a box plot. There are always 5 parts. We've got the lowest value, which is the start of the box plot. We've got the lower quartile, which is the start of the box. We've got the median, which is, if I can line it up right, which is the line in the box. Then we've got the upper quartile, which is the end of the box. And then we've got the highest value, which is the end. So when it asks us for the median is halfway between 10 and 12, which will be 11. And it will ask us for the interquartile range. Interquartile range, IQR for short, is the upper quartile, take away the lower quartile. So the upper quartile here is 18, and we're going to take away the lower quartile, which is halfway between 2 and 4, which will be 3. So it's 18 take away 3, which is 15. Okay, now next it says that the table shows results of cats. I think the first one was dogs. And compare the two distributions. Okay, you must always compare the medians. So looking at my dogs, or looking at my answer to the dogs, it was 11, and the median here is 15. So you need to write a sentence saying that the median for cats, which was 15, is higher than dogs, which is 11. So always state the values. Now you can also say on average they're higher because the median is 15 for the cats and only 11 for the dogs. As long as you're comparing the medians and saying which one's higher, or maybe they're the same. Okay, the interquartile range for the cats is 23 and for the dogs is 15. And the next thing you need to compare is a range. Now you could pick the overall range, or it's probably easier just using the interquartile range, and I've just done that wrong because the interquartile range for the cats obviously would be 23 take away 10, which is 13. That's very different. Right, so for the cats it's 13, for the dogs it's 15. Now 13 and 15 are not that far away, so you might say they are more or less the same, or you might say that the interquartile range is higher for the dogs. As long as you back it up with the numbers and say something that makes sense, then that's absolutely fine. The way of starting this sentence, so I said on average is kind of the way to start when you the sentence when you're comparing medians. For this one, you just say the spread of data for dogs is slightly higher than with cats. And then you'd say, since IQR, interquartile range for dogs, is 15 and for cats is 13. So whenever you're comparing the medians, you really should start with on average and then say the medians and write a comparative comment. And always start the sentence when you're comparing a range or an interquartile range with the spread of the data. And it just makes you makes the examiner realise that you know what you're talking about. Always include the numbers as well, and that's really important on some of the papers that you're referring to something. The first comparison is always the average, so the median, when you're comparing box plots or cumulative frequency graphs. And the second one is always the range, and that's really important to remember. The easiest way of approaching this question is to understand what multipliers are. Multipliers, you always start off with 100%. You work out what's happening, so let's say we're adding 40%, and then you work out the final percentage, which is 140%. The final thing you do is just convert it to a decimal. So divide by 100 to make it 1.4. That means you can multiply any number by 1.4 and it will go up by 40%. So in this question it says we have Billy, we have James, and we have Sam. And we're told that James collects 40% more sand than Billy. So he's got 40% more. We're told that Sam collects 20% more sand than James. So he's got 20% more. By what percentage has Sam got greater than Billy? Okay, now the obvious answer is 60. And if you write 60, unfortunately, you're not going to get the right answer. The way of doing this, as I said, is to understand multipliers. So, we imagine Billy starts off with 100% and he's gone up by 40%. So that means he's now got, or James has 140% of what Billy has. Now, as a multiplier, that's going to be 1.4. So whatever amount Billy has, we're going to times that by 1.4 to get James's amount. Then James then has the 100%. We add 20% on to work out what Sam has, which is 120% of what James has. As a multiplier, that's going to be 1.2. So we're going to times James's amount by 1.2 to work out Sam's amount. Now the problem is we don't know what the amount is, but we do know what we're going to do to it. We're going to times 1.4, then times 1.2. So, if we get our calculator, or if it's a non-calculator paper, then you have to do this the long way. And I type in 1.4 times 1.2. And that will tell me in total what I'm timesing Billy's by to get straight to Sam's. Like so. The answer to that is 1.68. Now that's as a decimal. If I convert that back into a percentage, that means Sam, if Billy has 100%, that means Sam has 168%. So therefore, Sam has 68% more than Billy. Now, if you're adamant the answer is 60, you need to go through this, because this is why this is such a high topic, is understanding that actually it's not going to be. And the government, with all their statistics, all the time use this, and people think, oh, it's 60%. It's not. It's 68% for this question. So this question asks us to factorize, and this is a kind of special type of quadratic. Basically, one way of thinking about this is we've got an x squared plus 0x minus 121. So we need to find two numbers that multiply together to make minus 121 and add together to make nothing. Now the only way you can get two numbers that add together to make 0 is if they're exactly the same number but one's positive and one's negative. So we know that they're going to have to be the same number. So when I put in my two brackets, because it's a quadratic and I put an x at the start of each, we know they're going to have to be the same number. Now 121 is not a number that's just been made up, it's always going to be a square number, otherwise this doesn't work. And one of them will need to be positive and one of them will need to be negative. Now if you expand that, you will find out that you've got 11x plus minus 11x, which cancels the x's out, which is why in the question there's no x terms. It's called difference of two squares if you wanted to look it up to revise it. So this question involves composite functions, FG, and the way this works is that the letter closest to the bracket always goes first. It's like a line, people or functions lining up, and then F will go after G's gone. So G is this bit here, okay, so 3x minus 3, and then we're going to feed that into function F, which is just times it by 5. So we're going to start off doing function G, and when we've done function G, we're going to do function F, which just multiplies it by 5. So 5 times 3x is 15x, 5 times 3 is 15. Now it says it equals 30, so we're going to get equal to 30. In fact, I should really put all of these equal to 30. And then we're going to put our lines in and solve it. Oh, line went a bit short there. Okay, so we're going to add 15 to both sides. So that gives me 15x equals 45, and then divide both sides by 15. So we have x equals 3. So the answer to this is x equals 3. Okay, so the first thing to do in this question is notice that we've got a bracket squared and another bracket squared. So the first thing to do is you need to write those brackets twice. If you don't do that, you end up squaring the 3 and squaring the root 2 and then thinking that you're going to get the right answer. Unfortunately, you can't get the right answer with just squaring the two of them because they are quadratics. So I'm going to write them out as two brackets because anything squared is itself times itself. Okay, now we're going to expand these. Now I'm not going to go into the methods of expanding quadratics, but we've got loads of videos on our channel, on our website to help you with that. So use whatever method you are comfortable with, whether it's FOIL or smiley face or whatever you want. I'm going to put them into brackets though. So 3 times 3 is 9. Then we've got plus 3 root 2 plus 3 root 2, so plus 6 root 2. And then we've got root 2 times root 2, which is plus 2. Okay, so second one, 3 times 3 is 9. And we've got minus 3 root 2 minus 3 root 2, which is minus 6 root 2. And then we've got minus root 2 times minus root 2. 2 minuses make a plus, and root 2 times root 2 is root 2. Now, the reason I kept them in brackets is because this is really important. There's a minus 1 there, and it means we've got to multiply everything in the second bracket by minus 1. So the first bracket's unaffected, so we're just going to get rid of the brackets there. Don't need to worry about that. But the second bracket, I need to times everything by minus 1. So that first one is minus 9. The second one is, well, minus times a minus is a positive 6 root 2. And then a minus times a positive is a minus, so minus 2. That means that we can cancel out the 9s there. We can cancel out the 2s there. And all we're really collecting here are the roots. So 6 root 2 plus 6 root 2 is 12 root 2. Now it says it wants it in the form a root b. So a is the number outside the surd, which is 12, and b is the number inside the surd, which is 2. This question could be a show that question where it gives you the decimal and the fraction, or it could just ask you to work it out. So it could turn up on either paper. So the first thing I'm going to do is just convert this. I'm just going to be investigating this first, and then I'll worry about the 0.0 later on. Okay, so way of doing this is get x equal to 0.8686 blah 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 recurring. Now we need to bring that 86 in front of the decimal point, so I'm going to times it by 100. So I'm going to work out 100x is 86.8686 blah blah blah. And then what you do is you just take away going downwards. The reason we do that you will see in a second. So 99x, because it's 100x take away x, which is 99x, and it's 86 point recurring pattern take away 0 point recurring pattern. The recurring patterns take away, so we're just left with 86. I'm then going to divide both sides by 99. So it's x equals 86 over 99. Now, I said I'd ignore the 0.0 bit. I'd ignore this bit earlier. Well, I can't ignore it anymore. So how do I get from 0.86 recurring to 0.086 recurring? Well, I'm just going to divide by 10. So what I want to do is I want to do 86 over 99 divided by 10. Now the way I can do that is just times the bottom of the fraction by 10, and that's the same as dividing it by 10. And we should write 0.086 recurring equals, to show the examiner that that's what we're doing. Okay, so we can cancel at this point. If you have a look, we can divide top and bottom by 2. So we're left with, I can show that I'm dividing by 2. So we're keeping the fraction the same. So that will be 43 over, and half of 900 is 450, half of 90 is 45, so it would be 450 plus 45. And you don't need to show this working out, but I'm doing it just to show you. So it'd be 495. Now, I don't think there's another number that goes into 43 and 495, so I'm going to sort of leave it there. Normally when you're asked to simplify, or normally when the numbers are big, you won't be asked to simplify it, or there will be a very easy way of simplifying it. The place to start with this question is just understanding that there is a triangle, and you might not know that there is a triangle for this. Because you might be taught it in a slightly different way, but if you were to draw a triangle for us, frequency density and class width were at the bottom and frequency at the top. Now it's a little bit misleading because actually this is proportional to the frequency density, so it's technically proportional to each other. So if you did frequency divided by class width, you might get half of what the frequency density is. So just be a little bit careful, and if they're looking for that type of question, they will give you a bar on the histogram and a value in the table that show you what you have to times them by to get to the frequency density. However, in this one we're actually asked to draw a histogram ourselves, so we don't need to worry about it. Okay, so the first thing I want to plot is our class widths on each of these, because I'll need to know what they are. So the first class width, where it's 0 to 10, so the class width is 10. The next one's 10, and be careful because actually the next one is 20 to 25, so that's only 5, that one. The next one's 10, and the last one's 15. So when I've got the class width, I can work out the frequency density. And the frequency density is the frequency according to the triangle divided by the class width. I want to divide these. Okay, so we've got 9 divided by 10, which will be 0.9. 1 divided by 10, which is 0.1. 6 divided by 5, well that's 1.2. 3 divided by 10, which is 0.3. And 6 divided by 15. Well, if I've got a calculator it's easy, but here I can divide top and bottom by 3, so that's 2 over 5. So that's 2/5, which is 0.4. Okay, now notice that the frequency density is not plotted for us, so we've got to come up with a scale. Our highest one is 1.2, so can I go up in ones? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 2, so that would be perfect. So I can go up in ones on the 5 squares, so it would be 0.2 here, because they're 2 squares, 0.4, 0.6, 0.8, 1.0, or just 1, and then 1.2 at the top. Okay, now next thing I want to draw the bars. So our first bar is 0.9 high, and it's 0 to 10, so we want 0.9 high, which will be here, and 0 to 10. Okay, next one is 10 to 20, and it's 0.1, so it'll be down here. I'm not going to get these exact, but with your one it's a bit easier to get exact. So 20 to 25, so we've got to be careful with this one, because it's only one square across. Let's try and get it as close as I can. So that's 1.2, but it's only 1 square across. Okay, next one, 25 to 35 is 0.3, so that would be there. And last one is 35 to 50 and 0.4. So we go up one, and then we finish that off. Excellent. Okay, so the next question says work out an estimate for the number of trees greater than 40 meters. So I want to draw a line up from 40, and we want it to go across here. So we're looking for an estimate for the amount that are in here. Well, if you look at it, I've shaded in 2/3 of that last group. In the last group there are 6. So I want to find 2/3 of 6, because the total frequency for that bar is 6, and we're looking for 2/3 of it. Well, 1/3 of 6 is 2, so 2/3 of 6 is 4. Okay, so for this question, this is all about linear, area, and volume scale factor. So, with this question, from B to A, we can work out the linear scale factor. So what do I times 5 by to get to 10? So the linear scale factor is going to be big divided by small, which is 2. Now the area scale factor is always the square of the linear scale factor. So we square it, and it's going to be 4. The volume scale factor is always the cube of the linear scale factor. So we cube the linear scale factor, and it's 8. So with this first question, it says cuboid B has the volume of 80. So if B has 80, the volume of A is going to be 80 times the volume scale factor, which is 8. So that's going to be 64 with a 0, so 640. And it's that simple. This one here, it says cuboid A has a total surface area of 440. So work out the surface area for B. Now this is surface area this time. So it's going to be 440. Now because we're going from bigger to smaller, we're going to divide by the scale factor. And it's the area scale factor we need, which is going to be the 4. So we do 440 divided by 4, which is hopefully 110. And it's that simple. So you just got to remember that if you have a linear scale factor, you square it to find the area scale factor, and you cube it to find the volume scale factor. Now there are 2 things you always want to try and get rid of when you're rearranging equations or formulas. The first thing is fractions. So this fraction here we want to get rid of, and we do that by timesing both sides by y minus 5. So I'm going to write out the equation again just to make it a bit bigger. And we can imagine that there's brackets around the top and bottom of this, and that sometimes helps us to answer the question. I'm going to put my lines down. So the first thing I want to do is times both sides by that y minus 5. and you must do that. You can't access the numerator of the fraction otherwise. So this ends up with being x brackets y minus 5, and on the right hand side it's just the same numerator but without the denominator. Now I said there were two things you've got to get rid of. The first one's fractions, the second one is brackets. You've got to break them open. So we're going to times out these brackets. So we're going to have xy minus 5x. And the right hand side hasn't changed at all, it's just 10 minus 3y because we haven't done anything to both sides. So what I want to do is try and get all of the y terms to the left hand side and all of the other terms, so the x terms, the number terms, whatever, on the right hand side. So I'm going to add 5x to both sides, but I'm also going to take away, add 3y to both sides as well. So I'm doing 2 in 1 here. So it's xy plus 3y, and on the right hand side we've got that 10 that hasn't moved plus 5x. Okay, when we have this situation where we've got the brackets gone away and everything is, all the y's on the left hand side, and y is what we're looking to do it in terms of, what we want to do is factorize it, so we've just got a single y. So y on the outside, x plus 3. Now I know I said I wanted to get rid of the brackets, but we need the brackets here to be able to get y on its own. And the last step here is we just divide both sides by the x plus 3. So we get y on its own. So we get y equals 10 plus 5x over x plus 3. So let's put that into our answer box. Now it can be either way around here. It could be 5x plus 10. That's absolutely fine. Still the right answer. Over x plus 3. Okay, here we're asked to simplify an algebraic fraction, and whenever you've got quadratics and algebraic fraction and you're asked to simplify it, always factorize them. Now this is pretty complicated because this is two quadratic equations where a, which is the coefficient of the x squared, is greater than 1, but it just takes longer. It's not really more difficult, just more stuff to it. So we go times these together, which is 60. Well, technically minus 60. And we need two numbers that that add together to make the minus 11 here. So I think they're going to have to be, you're probably going to have quite a big negative number and quite a small positive number. So thinking about it, probably minus 15 and 4. So 15 times 4 is 60. Therefore, minus 15 times 4 is minus 60. And minus 15 brings us all the way back to minus 15, and then add 4 moves us back to minus 11, so that works well. Okay, next step to do is we rewrite the quadratic, but instead of minus 11x, we're going to write minus 15x plus 4x, which is the minus 15 and the 4 we had, minus 20. If you don't understand any of this, please look at our videos on factorizing quadratics, which goes into this a little bit more detail. Okay, so we're going to divide out the 3x here, so we're left with x minus 5, and we're going to divide out the 4, so that would be 4 brackets x minus 5, and then we put the repeating bracket and the leftover pieces together. So we've got 3x plus 4, and then we've got the repeating bracket there. Okay, one down, one to go. So the next thing we need to do is do exactly the same thing again. Oh, the wrong one. Exactly the same thing again here. So that'll make 110. Now, we need two numbers that times together to make 110, add together to make minus 21. So we know both of the numbers will be negative. And to be honest, when they use numbers as high as 110, chances are it's just going to be 10 and something. So this will be minus 11 and minus 10. They try not to be too mean with it. You'll never get any of the numbers that are higher than 12, probably higher than 10,
unless there's an easy second number. So if it's like 15 and 2, or for example 15 and 4 we had before. Okay, so we rewrite this one, but instead of that minus 21x, we do minus 11x minus 10x plus 55. So same as before, we're going to factorize these and factorize these separately. So we're going to divide out the x here. I don't think there's anything else, no. So 2x minus 11. Now we're going to have the minus here, and I think there's a 5 we can get rid of. So 5, and then 2x. Now be careful with this bit. To get that plus 55 when we expand the bracket, this needs to be negative here, and that's a common gotcha for people, but we know that this must be a repeating bracket, so that can help us out sometimes. We can look at the repeating bracket and go, oh hang on, it needs to be a minus for that bracket to be repeating. So x minus 10, and then put the repeating bracket. Wow, okay, right, so I'm going to rewrite this fraction here, but this time with its factorized versions. So we've got bracket 3x plus 4, x minus 5 at the top, and at the bottom we've got x minus 5, 2x minus 11. Okay, now we're going to cross out the repeating bracket at the top and bottom. So we're going to divide top and bottom by x minus 5. So that gets rid of that and gets rid of that. So we're left with 3x plus 4 and 2x minus 11. Now these questions are really good to be practicing factorizing quadratics, because you get 2 for the price of 1 with these ones. But for your answer you don't need to put the brackets, because there's only those expressions at the top and only that expression at the bottom. But if you can go through these, also a little bit of a hint is, because when you're simplifying algebraic fractions, I mean you'll pretty much always get a bracket in the top and bottom to simplify at the end, to cross out at the end, otherwise you can't simplify it. So if you've done the top, you can actually cheat a little bit and work out, you know, the fact that the bracket at the bottom will either be 3x plus 4 or x minus 5, and that can help speed things up. You can also check your answer, because if you don't have a repeating bracket at the top and bottom, then you know you've probably done something wrong. Okay, so this doesn't seem like the easiest questions, because there's 3 shapes going on. There's no numbers in it at all, and we're asked to find a formula. So the first place I'd start is working out, well, first of all, what are the formulas we'll need? Well, let's have a look. So we've got a hemisphere. And some of these formulas you will be given. So a hemisphere is a volume of a sphere and then halved. So instead of 4 over 3, I can just say 2 over 3, which is half of 4 over 3, pi r cubed. The cone that we've got is going to be 1/3 pi r squared h. And then the cylinder we have is the area of the circle times the height. Okay, now we need to find out what the bits are. So for the hemisphere we just need r. Well, that's quite simple, because r is just going to be x. It's the radius of the hemisphere. Okay, now what's more difficult is to work out the height of the cone. Well, if the radius across to the right is x, the radius of the circle up is also going to be x. So we know the height of the cone is going to be 4x, because one of those x's is used on the hemisphere. We know the radius of the cone is going to be x, because it's stated at the top. So let's keep going. The radius of the cylinder is going to be 10x, and the height is just labelled as h. So that's nice and simple. Okay, now let's have a look at what this question's saying. It's saying that this thing here is going to be melted down and is going to be used to create this. So that's just saying that the volumes are going to be the same. So if I add the volume of the hemisphere to the volume of the cone, it should equal the volume of the cylinder. Okay, so we know that hemisphere plus the cone volume, and I should write volume here, show the examiner that I'm working with volumes, equals the volume of, I don't know why I wrote an S, my goodness, C for cylinder, wow, tell my maths teacher, right, cylinder, there we go. So hemisphere is 2/3 pi, and we said that x was the radius, so x cubed, brilliant. So plus the cone, now what did we say the height of the cone was? We said the height of the cone was 4x. So it's going to be 1/3 pi x squared, because the radius is x, and is it 4x? Let's double check that. Always double check. Yeah, it is. Okay. So the cylinder, and I'm going to leave that up so I can see it, is pi, and what's the r? So pi times 10x squared, and all of that squared, because all of that is r, times the height, so times h. Okay, so this is the formula we've got to work with. I'll put my lines down. Okay, so what we got? Let's sort out the timeses first, and let's tidy this up. So that hasn't got any timeses in it. This we're timesing it by 4, so it's going to be 4/3 pi, and I'm timesing it by x, so that's going to be x cubed. This one, I'm doing the 10x squared, so I need to square the 10 and the x, so it's going to be 100. And let's do the pi next, pi, and it's going to be x squared h. Okay. Now, if you notice on the left-hand side, these two here are the same. There's both pi x cubed. So we can just add them together. So it's going to be 2/3 plus 4/3. So that's going to be 6/3, or just 2. So it's going to be 2 pi x cubed equals 100 pi x squared h. Brilliant. Okay. Now let's just check to see what it wants. It wants a formula of h in terms of x. So it wants h equals. Okay. So first thing I need to do, well, let's have a look. What's easy to do? Well, what's easy to do is just divide both sides by pi. Let's get rid of the pi's. So 2x cubed equals 100 x squared h. Now we want h on its own, so we're getting close. We need to divide by the x squared first to get h on its own. So I'm going to divide by x squared. So we get 2x equals 100h. So we can already see we're really close. So to get h on its own, we need to divide both sides by 100. And that's going to be 2x over 100 equals h, or h equals, and we can cancel the 2 and the 100. We can divide them both by 2. Equals x over 50. So our answer is h equals x over 50. Okay, so this looks like a quite simple question. However, it's a little bit more complicated than it looks. It says that the sum of 3 consecutive numbers is divisible by 3, and we've got to prove it. So the working out is everything. So I'm going to name my first number x, okay, because we don't know what it is. It could be anything. But the next number will be x, same as the number before, but 1 added to it. And the next number after that is going to be the same as the first number, but 2 added to it. And it says the sum, so what we're going to do is we're going to add these three numbers together. So x plus x plus x is 3x. 1 plus 2 is 3. Now, this hasn't proved that they're divisible by 3 yet. All I need to do now is factorize this out. So I'm going to divide each of those by 3. Now that now is proof that they are divisible by 3, because if you times any number by 3, it will be in the 3 times table. So my proof is this bit here, and I could write a sentence saying any number that I times by 3 will be divisible by 3. And on the site, that's all you need to put in.
Okay, so a circle theorem question. With these questions, it's really important that you set all your working out and you give reasons for every step. So I'm going to do it one way, and there probably are slightly different ways of doing it. And as long as you give the reason, then that's absolutely fine. We're asked to find ODF, and just to help us, I'm just going to mark that on. So it's that angle there. Now, just finding this angle here, which we're going to start off with, it doesn't mean that it's the same angle as that. You can't guarantee that the arrow is going to be symmetrical. So we're going to start off with this one. But how do I show the examiner that's the one I'm starting off with? Well, the letters are there so you can actually write down what you're trying to find. So I'm looking for angle OBC, and you could write the word angle or angle OBC, or you can just do a little angle on top of the B. And we know that that's going to be 90 take away 51, and the reason is that angle between tangent and radius is 90 degrees, and that's one of the circle theorems. So AC is a tangent, and OB, because O is the centre, is a radius. So the whole thing's going to be 90. So when I do that, so I'm going to do 90 take away 51, which is 39 degrees. So we know that that's 39 degrees. And it's absolutely okay to mark it on the diagram as well. And actually sometimes, not often, but sometimes the examiner will look at the diagram and might give you some extra marks because you didn't show the working out. But most of the marks for these types of questions are for the reasons, and you can't really show reasons on the diagram in a way that the examiner is going to be able to see it. So I also know, let's have a look what else I can work out. Well, that's also 90 degrees, and that's also 90 degrees. And ADOB is a quadrilateral. So we can work out which angle we're going to pick next. Well, let's pick this angle here next. So what's that? DOB. So angle DOB is going to equal 360 take away 30 plus 90 plus 90. Okay, so I need to give a reason. Well, let's work it out first, and we can give a reason afterwards. So we're going to take away, 880 plus 30, so that's 210 from 360. That's going to be 150 degrees. And the reason is angles in quadrilateral. And we should really say that the angle ABO and ADO are angles between a tangent and radius as well, but I'm not going to. We've already used that reason, and it's clear in our diagram that we've just repeated the same reason. Okay, so angle DOB we've got as 150. So let's mark that on our diagram. So we can work out this angle here. Okay. And it's very difficult to know what to call this angle because we've already called DOB once. So we could call this other DOB. Let's go for that. Other DOB equals 360 minus 150. Okay, and the reason for that is just angles on a point. So that's 210 degrees, angles and a point. Okay, so what are we up to next? Well, we can work out this angle here, and actually let's mark on the 210 as well. So we've got it all on our diagram. We can work out angle DFB. So DFB, and this time we're using the circle theorem that says angle at the centre, which is the 150, is twice the angle at the circumference. So angle at the centre is twice the angle at the circumference, so it's going to be 150 divided by 2, which is 75 degrees. So angle at centre twice angle at circumference. Now, if your teacher's given you different ways of writing the circle theorems down, that's absolutely fine. There is no strict way of writing it down. So that's going to be 75 degrees. And if you look, we've got the arrowhead BFDO, which is a quadrilateral, and we've got 3 of the lengths. So we can work out ODF. I'm going to have to scroll up because my memory is not that good. So we're going to take them all away from 360. And what is it? 210, 75 and 39. Okay, so we're just going to take those away from 360. And obviously if you're doing this in the calculator paper, then please feel free to use a calculator. And we get 36 degrees. And again, it's just angles in quadrilateral. As a rule of thumb, my experience with these questions is they're normally looking for between 2 and 3 reasons. Obviously on this question there's an awful lot of reasons, but if you walk out of the exam and you just think, oh hang on, I only wrote down 3 and actually there's a 4th, sometimes you'll get the full marks, so don't panic too much. Just when you're doing the question, try and write down as many reasons as you can. Even really obvious ones like angles on a straight line or angles in a quadrilateral will help you get the marks. Normally, again, for circle theorem ones, they're looking for circle theorems as well as those ones. Okay, the first question asks us to find where the y-intercept. Now, at the y-intercept, x is 0. So if you have a look at our equation, these two will be wiped out because anything times 0 is 0. And we're just left with y equals minus 4. So x is going to be 0 and y is going to be minus 4. So that's nice and easy. And basically, whenever you just have a number in an equation, the y-intercept is that number. So it's going to be minus 4. The next question is pretty complicated, so we're going to break this down. It does ask us to complete the square. It gives us a bit of a hint. So I'm going to start with completing the square. So we've got x squared minus 8x minus 4. And to complete the square, what we do is we put brackets and we do x, and we do half of the coefficient of b. So half of this, and b is always the number before the x. So half of minus 8 is going to be minus 4. And we close bracket and put a squared there. Now if I expand that up here, x times x is x squared. Then you have minus 4x, and plus 16. So we get x squared minus 8x plus 16. Now, we want the x squared minus 8x because that's what the equation in the question is, but we don't want this bit, that plus 16. So we're going to subtract, get rid of the 16 by taking away 16 there. And we've also got the minus 4, which is in the question to have as well. And we do have videos on completing the square, which go into it a little bit more detail I'm going through here, so watch those if you're not sure. Go put the minus 16 and the take away 4 together. Okay, so here we've got an x and we're subtracting 4, we're going to square that and then take away 20. Now, the next thing to think about is comparing it to y equals x squared. Okay, y equals x squared looks something like this, and I'm going to do a really bad job of doing this, but something like this, okay? And that's y equals x squared. So if you think about that function, and we're going to call that f of x, then what's happened between that and the one that we've just created? Well, in terms of f of x, this one is going to be f, which is the function is squaring, of x minus 4, okay, and we're going to square it, take away 20. So think about functions. What do the bits do? Well, anything in here moves it in the opposite direction on the x-axis. So minus 4 would move it 4 to the right, and anything in here will shift it on the y-axis, and actually it will be in the correct direction. So anything inside the bracket affects the x in kind of the opposite direction, and anything outside the function will just affect the y. So the minimum point on y equals x squared is 0, 0. And we're moving to the right 4, and then we're moving down 20, so it'd be minus 20. So the new point will be at 4 minus 20, and that's going to be the point at t. A little bit complicated, but once you get really good at completing the square and really good at understanding transformation of functions, then this question just brings the two together and you shouldn't have a problem. If you had any issue with this, obviously have a look at completing the square and have a look at transforming graphs and transformation of functions, and that will help you massively with this. This question might just ask you to rationalize the denominator. It might ask this question the form that's in, or it might ask you to show that that fraction is the same as another one, where you'll get marks for the working out. So to do this one, what rationalizing means is basically what this one's here, because if you look, there's no root at the bottom there. What rationalizing means is to get rid of the square root off the bottom of the fraction. Now I'm going to write this out again to make it a bit bigger. Now the only way we can do that with this question is if we times top and bottom by kind of the opposite of what it shows at the bottom. So instead of 11 plus root 5, I'm going to times it by 11 minus root 5. But if I do that to the bottom, to keep the fraction the same, I must do it to the top. So that creates a kind of quadratic surd. Okay, you do it the same way as you do quadratics, whichever method you want, first outside, inside, last, or double smiles and rainbows, or smiley face, or whatever you choose to do it. So I'm going to do the top first. So I'm going to do 5 times 11, which is 55. I'm going to do 5 times minus root 5, which is minus 5 root 5. I'm going to do 11 times root 5, which is 11 root 5. I'm just going to extend my line a little bit. And root 5 times minus root 5, well, a positive times a negative is a negative. And any surd, when you times it by itself, it just becomes that number. So root 5 times root 5 is just 5. Okay, let's do the same with the bottom. So 11 times 11 is 121. We've got root 5 times 11, which is plus, it's 11 root 5. Then we've got minus root 5 times 11, which is minus 11 root 5. And then we've got positive root 5 times negative root 5, which is minus 5. Okay, now you might see what happens at the bottom. The whole purpose for doing this is you end up with the surds cancelling each other out. So let's simplify the top. 55 take away 5 is 50. And minus 5 root 5 plus 11 root 5 is going to be, well, if you think about it, you've got 11 of something and you're taking away 5 of it. Well, what you're left with? Well, you're left with 6 of it. So it's plus 6 root 5. Okay, now let's go through the bottom. Well, the two middle ones have cancelled each other out, so it's 121 take away 5, which is going to be 116. Okay, can I do anything else with this? Well, I don't think there's something that's in 56 and 116 apart from 2, so we can cancel all of that. We can halve all of those, so that becomes 25, that becomes 3, and that becomes 58. Now the 3 doesn't go into 25, so we can't cancel it any further, so it's going to be 25 for A. B is the coefficient of the root, so it's going to be 3, and the bottom number is 58. There are a few different methods to answer this question, but I prefer the method where we just replace f of x with y because it becomes a lot easier. So I'm just going to write out the same equation. Now, when you want to find the inverse, which this is, of the function, all you do is swap the y and the x around. So we're going to have x equals 4y minus 10 over 7. And then all we need to do is get it so we've got y equals. So the first thing I'm going to do is times both sides by 7 to get rid of the fraction. So we've got 7x equals 4y minus 10. Then I'm going to add 10 both sides. So we've got 7x plus 10 equals 4y. And then I'm going to divide both sides by 4. So I've got 7x plus 10, all of that over 4, equals y. Now, it's not y really, it's f, inverse of function, x equals 7x plus 10 over 4. And the 7x and the plus 10 can be either way around. So 7x plus 10 over 4. I hope you enjoyed that video. If you did, please click like, and if you really enjoyed it, please click subscribe. Also, make sure to check out our website. Our website has a lot more on it, and you can just revise anything you want. Finally, very, very good luck for those of you doing the resits in November, and I hope you get the result you want. Thank you very much.